Hello my dear students, how are you all? My dear students, today we are going to cover a very important topic from the examination point of view, which is present in chapter number 14 about metals. And today we are going to learn about the reactivity series of metals. You know that more than 90% of the elements in the periodic table are metals. And why they are metals? Because they are capable of losing their electrons and forming cations. Now, this process makes them metallic. And how they behave and how efficiently and quickly they form their cations. It's about their comparative study in which all metals are arranged in the reactivity series. So we see how it looks like. We can see all of the metals, normally common metals. The metals are arranged in some order, and that is the order of reactivity. So the series begins with the most reactive metal, potassium, and the series ends up at the least reactive or highly unreactive, means the stable most element, gold or platinum. So we see it's a long series, so it's not easy to remember it. So people are making some of the mnemonics which will be helpful in learning this series, like they have using the beginning letter with a new word, and as they are made into a sentence, so it will be helping. Sometimes it is really helpful to learn those series, as it is please stop calling me a careless zebra. Instead, try learning how copper saves gold. So please means potassium, stop comes from sodium, and this is how the series will help you. But you have to remember one thing, that the topmost level is the most reactive, and the bottommost, the lower level, is the gold, which is for the least reactive metal. Okay, one more thing to know about the reactivity series, that any element which is above the lower one is higher in reactivity, as potassium is more reactive than sodium, and sodium is more reactive than calcium and all the underlying elements. And similarly, carbon will be higher in reactive as compared to iron, tin, lead and all the underlying or lower metals than it. So we see, first we will understand the reaction of alkali metals with water. I tell you here that we will be arranging the metals in the reactivity series on the basis of two reactions. First, reaction with water, and then reaction with hydrochloric acid diluted. So here are the series of all the reactions with water. First, we check the reactivity or response of the metal with cold water. So here are some pictures which are showing that reaction can be like this, producing bubbles of something, bubbles of a gas, and making the water milky, or it's just warming up the content. Next, the reaction can be violent, and you can see some flaming spark in the liquid, but at the same time there are some metals which are very violent when they react with water. So how it happens, you can see the metal is reacting very violently with cold water. So while performing these reactions, one should be very careful. Now we see how they behave. When group 1 metals or alkali metals react with water, they produce their hydroxides and hydrogen gas. Similarly, lithium forms lithium hydroxide and hydrogen gas, and sodium reacts with cold water to produce sodium hydroxide and hydrogen gas. Now, how it happens and what are the observations we are going to discuss in the coming slides. The next we see the calcium, which is the third element in the reactivity series. It is reacting with water to produce calcium hydroxide and hydrogen gas. So as you see, the bubbles are seen there, and the cold water, colorless water, is turning milky due to the formation of calcium hydroxide. We can also see that magnesium, the fourth metal, is reacting with cold water to turn it milky. And we also remember that whenever magnesium is lighted or is burned in the air, it produces white spark. We have to apply this observation in the coming slide. Then we see the fifth metal, zinc, shows no reaction with cold water. But why this is so? First four metals are reacting with cold water, but the next underlying metals are not reacting with cold water. So what is the other way to check their reactivity? Yes, we have steam to check their reactivity. So you see the top metals are comparatively very reactive as compared to the underlying metals. So we'll be seeing that the top very reactive metals are showing their reaction with cold water. Now we see what kind of observations are we getting. In case of potassium, when we add cold water, we see the reaction is very violent. As you saw in the previous slides, it was very violent, and the flame or fire was seen there because the reaction was very violent and a lot of heat was evolved. So reaction must be exothermic. So what are the products? Potassium hydroxide and hydrogen. As potassium is there and hydrogen gas is there, potassium metal can catch fire and giving some violet color flames. So the reaction is very violent, means the potassium is very reactive. Then with the second metal, sodium, the reaction is still violent, producing sodium hydroxide and hydrogen gas. We won't be observing this bubbling hydrogen because the reaction is very violent and the hydrogen gas catches fire. As sodium is there, it can also be burning to give golden yellow flame color. The next is the calcium. Calcium readily forms calcium hydroxide. Now you have to understand the occurrence or possibility of this reaction, or in other words, you can understand how reactive the metal is by its observation. So first you have very violent, means most reactive. Then we have violent, means highly reactive. Next is coming calcium. It readily forms calcium hydroxide and hydrogen gas. Now in this case you can see the bubbling hydrogen because the reaction is normal. Now the next fourth metal reacts slowly with cold water. Now this slowly means the reaction is taking place without release of heat here. Although it releases energy, but not as much as it was released in the case of potassium, sodium. And you can also see the bubbling hydrogen. Now the fourth case, which is magnesium, it reacts very slowly with cold water to form magnesium hydroxide and hydrogen gas. Now same is the metal which reacts slowly with cold water, but now we see how magnesium behaves or reacts with steam. And what is steam? Yes, These are hot vapors of water. Look, magnesium reacts violently with steam. Means a lot of energy is evolved, and a white solid is the product, that is magnesium oxide, and the other product is hydrogen. Now you compare the products of reactions of metals with cold water and with steam. In case of cold water, you are having hydroxides of metal, but in case of steam, you are getting oxides of metal, but hydrogen is produced in both of the cases. Now we had not studied the reaction of reactive metals with steam, because as they are very reactive, the reaction is almost explosive. So we do not perform these reactions in the lab. Now we see, as hydrogen gas is produced there and the reaction is very violent, so hydrogen will catch fire to give very bright glow, and magnesium is there. You know, magnesium burns in a white glowing spark. So this is a very important observation in case of magnesium. Suppose you can be asked a question that what is that metal that reacts with cold water slowly but reacts violently with steam to give white glow? And the answer will be magnesium. Now the next is zinc, iron, and lead, copper, and silver, gold. Now these metals are showing no reaction with cold water because of their stability or least reactivity. And zinc and iron shows their reaction with steam but not with the cold water. Now we see what are those observations. The hot zinc reacts readily to steam, forming zinc oxide. And zinc oxide has two colors at two temperatures. The observation is, when zinc oxide is hot, it is yellow, and when it is cold, this is white. And hydrogen gas is also produced. So these two oxide colors at different temperatures will be its identity, means identity of the metal. So these kind of distinguished colors are very helpful in solving the reasoning questions. The next is hot iron reacts slowly with steam to form iron oxide and hydrogen gas, and here the iron must be preheated, means it must be red hot, and it reacts with hot steam to give a very unique oxide. Yes, this is Fe3O4 and it is a solid, and hydrogen gas is produced. But one more thing to observe here, that lead, copper and silver, and then comes gold in the last, they show no reaction with cold water and no reaction with steam. The next we see how they behave with dilute hydrochloric acid. Now we see the reaction of potassium is very explosive, and this is often not performed in the lab because it is very dangerous and it can be very explosive. Yes, but the products are with hydrochloric acid is aqueous potassium chloride and hydrogen gas. Now third comes with calcium. Calcium reacts with hydrochloric acid to form calcium chloride and hydrogen gas. And magnesium reacts rapidly with hydrogen gas. Do you still remember the behavior of magnesium with cold water? It reacts slowly, and with steam it reacts readily. Similarly, magnesium is the fourth metal in this series and it's reacting rapidly to give hydrogen gas. The next is zinc. Zinc reacts moderately to give hydrogen gas. You see, the same gas is produced all the time, and iron reacts slowly to give hydrogen gas. Like, as the hydrogen is not at the very top position, iron is comparatively a stable metal, so its behavior with cold water and steam is almost in the same range, that it reacts slowly to give hydrogen gas. Means iron is a comparatively least reactive metal. And lead, copper, silver shows no reaction with hydrochloric acid. Now, after studying all the reactions of metals with water, steam, and hydrochloric acid, now we have understood that why these metals were arranged in such order. Now, coming to the application side, how the reactivity series will be very helpful for us, and why this is given in the course, because we are going to understand so many things after studying reactivity series. The very first is displacement reactions of metals. The next is how the metal will be reacting with another metal's oxide. Third, how possible is the reduction of a metal oxide with carbon. Fourth, reduction of metal oxide with hydrogen. And last is the action of heat on metal carbonates. So all these reactions are basically somehow very important to understand, to study about metals in detail, and to study about their reactions, and to study about their extractions. And very soon I will be coming up with the detailed discussion of all these five chemical sets of equations. And I'm very hopeful that this video will be very easy and helping aid to understand the topic reactivity series. Now wait for my next video and keep watching these videos and support me in making more videos, more help in future, and give me your feedback on the channel. Thank you. God bless you. Bye bye.